Okay, well, I think we can get started here. So I want to go ahead and welcome everyone, and thank you so much for attending this educational webinar on hydraulic breakers with us here today. We're very grateful that you took time out of your schedule to join us. So I'd like to go ahead and introduce our speaker, Doug Rosenthal, to you. He's coming to us with 15 years of experience. Doug is the West Coast Regional Manager for Toku America and lives in Arizona. Doug's territory covers Western Canada, which includes Alberta, British Columbia, and Saskatchewan, and the western third of the United States, including Alaska and Hawaii. You'll receive Doug's full bio with your handouts soon after this call. And Doug will be sharing information today regarding the steps required to service and maintain hydraulic breakers. Doug will also open the floor for questions after his presentation. But since we do have a small group today, feel free to raise your digital hand to ask a question during the presentation, or you can also add a question in the chat. So soon after the webinar, you'll receive the recording and a link to Doug's slide presentation and a few related handouts. So with that being said, please join me today in welcoming Doug Rosenthal.
Thank you, Kelly. I appreciate it, and I just want to just quickly mention a couple of people that I have on the call with me. So Russell Walton is joining me. He's a native to Canada, and he covers the eastern part of Canada for Toku. Russell, if you can just say hi real quick.
Yep. Thank you, Doug. Yes. Hello, everybody.
And then I also have Matt Gruden. He's the president of our company based in Cleveland, Ohio. Matt, you just say a quick hi.
Hi, everybody. Thanks again for having us. We appreciate the opportunity for Doug and Russell to talk a little bit about our products and a little bit about our company. We appreciate your attention.
Thank you, Matt. And finally, David Nakamura. David's Toronto native, and he's our chairman of Toku. This gentleman has 30, 40 years of experience with hydraulic breakers. He's probably forgotten more about hydraulic breakers than I'll ever know, and worked in our factory back in Japan. So extremely knowledgeable and a Canadian native to the Toronto area. Still has family in Toronto. But without further ado, let me hop into this. So today we're going to be talking about the overview, preventive maintenance, and storage of hydraulic breakers. This is a generic presentation, so regardless of the brand of breaker that you have in your rental fleet or that you're considering, this overview is meant to be helpful for hydraulic breakers in general. Hydraulic hammer users, so you got your contractors, you got landscapers that use breakers, homeowners that'll do some renovation, municipalities, they need to get into the streets, whether it's wet utilities or dry utilities, they'll need to open up trenches, and also utility companies. So that's just kind of the baseline of who uses hydraulic breakers. And of course, they're used in mass excavation and real rocky area, along with quarries and mines. Why rent breakers? They do have a very high ROI. The attachment costs about 10% of your carrier, right? So if you're running a $50,000, $60,000 skid steer, a hydraulic breaker is going to be about 10% of your cost. Where your rental, you're going to be able to get the same rental rate for that breaker as you will for the attachment. What we typically see across the board is if a skid steer, for instance, is renting for $225, $250 a day, they put a breaker on it. You can also get another $225 or $250 as soon as you add, and that correlates all the way up. So the bigger the machine, the bigger the breaker, the more rental you can get on there. And there is a low cost of ownership on a hydraulic breaker, as long as it's properly maintained. And we're going to talk about maintenance on the breakers. And for the most part, an easy setup, especially on the small breakers. There a lot of times, majority of the time, it's just plug and play. And one of the fastest growing segments that we see in North America are the walk behind skid steers and the breakers for those. Over the last really 3 years, this segment has grown exponentially for a lot of different reasons. In the rental market, I mean, safety alone. So you have homeowners, weekend warriors that are renting, they need to rent a type of skid steer. This gives them better visibility than your traditional skid steer, and the hydraulic breakers correlate right along with that. Let's talk a little bit about the components of a hydraulic breaker. So not in all, but in most, there's a nitrogen cushion chamber in the upper housing of the power cell. So this piece here of a hydraulic breaker is called the power cell. You have a control valve, a hose adapter, the piston, the tool, and this area right here is where we're gonna spend a lot of time talking about the maintenance. Is the way that this is maintained and stored is critical. And Kelly, if you can kind of keep an eye out, if there's any hands get raised, I can't see that part of the screen, so feel free to let me know. But this section here, we also call the strike chamber, because that's where the piston strikes the tool that breaks the rock or concrete. You have your chisel bushing. You have a retainer pin. Some breakers utilize a single retainer pin. Other breakers utilize a dual retainer pin system. Our particular breaker that we offer does use a dual retainer pin system. And then, of course, your tool. Now, some breakers have accumulators in them. The accumulator, the way that those are designed, it's to handle hydraulic surges in the system. They aid and assist with the firing of the breaker. However, this is a big maintenance item that if this fails, meaning it cracks or breaks and it's continued to use, you could have a catastrophic failure on the internal side of the breaker. And generally speaking, when accumulator needs to be worked on, you definitely have to know what you're doing. The pressure behind this is, 2,000, 3,000 PSI pressure behind it. And a lot of times you'll notice a lot of bolts around these to hold those down. So if the pressure inside that accumulator, the nitrogen isn't completely left out, and you have somebody that doesn't exactly know what they're doing, then you could end up sending this piece of steel through the roof of your shop. And we've heard lots of stories of different occasions where the accumulators have almost taken somebody's head off. So it's really important that if you do have breakers with accumulators, that you're working with a service center that knows what they're doing on those. And these accumulators do need to be replaced around 500 to 600 hours. But if you have them, be sure to check with the owner's manual to see what it says on it. Okay, now selecting the correct size breaker for your machine. Make sure that the carrier weight is within the recommended range. There is a 10% rule that we go by. So if it's a 550 foot-pound class breaker, you don't want to put it on bigger than a machine that's 5,500 pounds. So it's a 10% rule, and that gets into how tippy the excavator is going to be. So if you go more than 10%, that excavator is really going to tip on there. So the 10% rule. So the breaker foot-pound to the weight of the carrier of the machine or the excavator. Then you need to check the hydraulic pressure and flow that the machine can, your excavator, skid steer, backhoe has enough flow and pressure to be able to operate the breaker. The other important thing when you get into the larger breakers is the relief pressure is set properly. One of the things we work with our customers on, especially on the larger breakers, is that this operating pressure here, the relief pressure has to be greater than the operating pressure, because if you set your relief to the operating pressure, what's going to end up happening is the oil is going to start going over relief too soon. It'll build up heat into the system. The breaker won't operate at full capacity. So that's why if you take a look at these numbers here, you'll see that there's a difference, that the relief is set higher. Now, with that being said, one of the things on the older machines is if you're running a thumb on your excavator, that's where people will try to keep that relief pressure down, because if you have the relief pressure too high, you can bend or break thumb curl cylinders. And there's a way around that. That if you're in a situation like that where you have thumbs and you're concerned about the relief, definitely get a hold of us and we can help you. There's a couple tricks where you can reverse the setting on it, so the close on the thumb is on the return for a hydraulic breaker. One thing that's really important to understand too about a hydraulic breaker is it's one-way flow, one way in, one way out. There's a pressure side and a return side. When you're dealing with something like a thumb, it's two-way flow. So you need it to open and to close. So you have the oil will go in both directions, similar for an auger. So when a hydraulic breaker is being ran, it's important that it's in one-way flow. Because not only you need the pressure to go to the pressure side of the breaker, but also if it's in two-way flow, a lot of times on the return, the hydraulic oil return side, it's going back through the coolers, it's causing restriction, and it can actually build up heat in the system with the breaker running for an extended length of time. And when with heat, there's it causes stress on your hydraulic pumps, but also over time it can make your hoses start flopping around to the point where you could end up busting hoses. Any questions on any of this so far? No? Okay. All right. And the other thing too is back pressure, is to make sure that how much back pressure can the hydraulic breaker handle. Back pressure, one of the things when I mentioned it being in two-way flow running a hydraulic breaker, that's a spot that's going to cause some back pressure with the oil having to go back through the coolers and not directly to the tank, to the hydraulic tank. Other times we've seen lots of fittings when in the hydraulic lines that don't need to be there. And that's something else that'll cause back pressure, along with you could have say an inch hose or an inch and a half hose that gets brought down to an inch line going back to the tank. Things like that will cause some restrictions, and some breakers are extremely sensitive to back pressure going back to the hydraulic tank. And this is just a quick little video. You watch the oil here of how the breaker is fired. So every time the button is pushed or the foot pedal is depressed, that's when the piston's fired. This is your tool that's going to break the rock or the concrete. When it's depressed into the object, it's pushing this piston up into this nitrogen housing. And when it cycles, that's when the pressure of the piston is firing down to hit the tool. So it's really important. Why I bring this up or point this out now, there is something called a dry fire. So if there's no pressure from the tool on this piston, and this piston cycles, it's going to fire. But what's going to end up happening is the tool is going to end up taking all of that force, and it's going to end up hitting your retainer pins, and it over time will cause damage. So it's important that breakers aren't dry fired. Some breakers have different forms of an anti-dry fire, and where it's the full power, the full 100% of the power isn't being delivered. But over time, with a lot of dry fire happening, it'll cause damage internally. So it's important that you let your rental customers know they got to have down pressure on the tool when they fire this breaker. We've seen guys that will literally have the breaker in the air, start pressing, and then they'll go into the dirt or rock. Short term, but if they do it long term, it causes a lot of damage to the hydraulic breaker. Any questions? We doing good? All right. Okay, tool types. So these are the three standard tool offerings: moil, chisel, or blunt. So a moil is like the point of a pin. A chisel, if you can think of it like a flathead screwdriver, and then a blunt is just a rounded end. There's a lot of different protocols on who uses what. The general rule of thumb that I go with is if you're breaking concrete, then you would use a moil. Now, I'll tell you, if you're doing like precise concrete braking, you may want to do a chisel if you're trying to bust things off in a little bit better pattern, or even asphalt, something like that. We see chisels primarily used for concrete rock breaking oversize in quarries, things like that. And then blunt is for large boulders when they're really trying to bust oversized rock to feed a crusher. Any questions on tools? Okay. All right. Now this has to do with installing the tool. You do need to refer to the owner's manual for your breaker on the installation of the tool. There's a lot of different methodologies of it. The purpose of this for this presentation, what I want to point out is it is important to pre-lubricate the tool before you put it in. So this diagram right here shows they're putting chisel paste. Now we also recommend getting some chisel paste on the lower bushing and also on the upper bushing. So there's a couple bushings that can be replaced in a hydraulic breaker that they do need to be lubricated, and it's a good idea to pre-lube them. The only thing I would tell you is the very top of the tool, you don't need to put chisel paste on. You don't want to overcoat it and get it too much chisel paste on the very top. And we're going to talk a little bit about lubrication of a hydraulic breaker. But while we're here right now, I will tell you it's really important that on all hydraulic breakers you use chisel paste. You don't use moly. Your standard moly for your pins and bushings on your machine, you need to use a high temperature lubricant on your breaker. So this diagram here, what I want to point out is if on this first picture, so you have a breaker laying on the ground and your grease zerk is on it. What tends to happen is there's a void between the piston and the tool. So if this diagram was a little bit better, you'd notice that there's a big opening in this cavity right here. So if you put chisel paste inside of this area while the breaker is laying on the ground, meaning there's no down pressure on that tool, you could literally put tubes of chisel paste inside that breaker, that there's a big void. What happens is then now it's time to go to work. That chisel paste has got to go somewhere when this void is closed between the tool and the piston. The concern is if your chisel paste ends up going past your seals, you'll wipe out your hydraulic seal. So this thing will be dumping hydraulic fluid. So it's really important that whoever's getting on the get ready for the rental knows when they go to lubricate the breaker that it's on the machine and there's down pressure on this tool. So it's closing this gap. It's closing the gap, and this is the only area where you want chisel paste to be. So generally speaking, depending on the size of the breaker, you're only going to be able to do maybe 8 to 10 pumps of chisel paste when this is closed, when that gap between the tool and the piston, and it's pressing the piston back up in this area. You're not going to be able to do 30, 40 pumps of grease. And like I said, if this cavity gets filled with chisel paste, it could cause problems. And like I said, the grease has got to go somewhere. And if you get that grease to go past your seals, then it's going to require the breaker to be rebuilt. Any questions on that? This one's really important to understand. Nope. Okay. All right. So down pressure on the breaker when you lubricate it. Okay, this gets into the chisel paste. So the chisel paste is high temperature. Standard moly, the melting point in Fahrenheit is around 350, 370 degrees Fahrenheit. Chisel paste is closer to 2,000 degrees Fahrenheit. When a breaker operates, it's extremely hot. Like, it's important that if a customer is running the breaker for an hour or two, they don't touch the tool with their bare hands. They will burn their hands. It's extremely hot. It's usually pretty easy to tell if a customer is using or an end user is using the moly that they would use on their pins and bushings, because it'll literally start melting down the tool, and it tends to have kind of a pinkish color to it. We've seen scenarios where this rental customer was using moly, and it had melted to the point that the tool got so hot it welded itself to the bushing. So we literally had to take the breaker apart and press out the bushing with the tool attached. And then we could see the scoring of the red moly grease on it. So it's really important that wherever you're buying your lubricant from, find out if they offer chisel paste, a high temperature grease, and only use that on your breaker. It's a copper infused grease. So it's very important that it's only used on the breaker, that it doesn't end up in your pins and bushings on your machine, because it could cause damage to those. But on the breaker, it's absolutely critical that you have chisel paste to run any hydraulic breaker. Now, there are auto lubes systems that are made for breakers. These are just a couple examples. This one has a replaceable cartridge on it. As it's operating, this button will spin so the operator can tell that it's working properly. This is one that's used on a smaller breaker. It has grease zerks, so the operator can visually see how much chisel paste is inside of this. And then this is a machine-mounted auto lube. One thing I'll tell you, especially in Canada, chisel paste is very thick, and when it's extremely cold, then that chisel paste is very hard to move up the, if you can imagine, it's mounted on the excavator and it's moving up the boom, down the arm to the breaker. We personally don't recommend these. The breaker mounted auto lubes work a lot better. But these are options too, that you can use on pretty much any size breaker to ensure that it's being lubricated. Going to get into a little bit on operation. It's important that the hydraulic system's warmed up before a breaker's fired. And then you also want to make sure that you have a 90-degree angle to the surface. I've got a breaker operator guide that I'm gonna show you also. It's something that you can have at your rental counter, whether you use it to have a customer sign off that they understand, or we actually have some handouts that can be given to just about correct operation. But I always want to work at a 90-degree angle to the material. And this is really important. If it doesn't break in 20 seconds, change positions. Depending on if you're in a rocky area, if that rock doesn't break in after 20, 30 seconds, really what's happening is you're creating a dust pocket, and it's almost cushioning. So it's important that they reposition and start breaking on another area. This one talks about starting at the edge, voiding the blank fire. We talked a little bit about when the breaker's fired and there's no pressure on this tool. It's called a blank fire or dry fire, and all that shock is being delivered to the retainer pin or pins of the breaker, and over time it'll cause damage. And where we've seen retainer pins that have been completely destroyed inside of a breaker, and it takes quite a bit of work to get those out. And then this is do not operate underwater without an air kit being installed. So I don't know if there in certain parts of Canada you could run into a situation where breakers are being ran, whether it's in the Great Lakes or the ocean or lakes in the area. But it's important that the breaker, if it's in water, the water doesn't, and you don't have a supply line, it's really important that the breaker doesn't go, if the water level, if it goes here, if you can imagine, without that water, that air kit, the breaker is going to act like a syringe. So when it's fired and everything comes, it's going to suck water in. So not only will the water get sucked into the breaker, but now the water gets sucked into your hydraulic system. I've seen this happen in Hawaii, and it takes somewhere between 60 to 80 hours of flushing out the hydraulic systems, the excavator's hydraulic system, 80 hours, just completely flushing, trying to get all that salt water out. And if the breaker isn't taken apart right away after that happens, then the piston's going to rust, the bushings are going to rust. It's a bad deal. So it's really important that if breakers are going to be used in water, that there's an air kit, and you do need to refer to your owner's manual about how that works. Our breakers do have an area for a supply line, but I'm sure there's probably I don't know if anybody on this call has the opportunity where breakers would go to work underwater, but there are ways to do that. All right. This again just shows another example of the working to brake at 90 degrees to the work surface. One thing I just want to show this. It's important that when the breaker is being operated, that the cylinders aren't completely closed or completely opened all the way. So you want them centered, because with the cylinders centered, they're going to take the cylinders are built to take the shock. If they're completely closed or completely open, that's when you're going to cause damage to the carrier. So it's important that the cylinders are basically half open or half closed, however you want to look at it, but they're not completely extended on there. This is the guide that I talked about. Let me see. Just pull this up here real quick. So this is the operator quick reference guide. This is a booklet that we offer. It goes over everything for breaker operations, from job site survey to when you're running the breaker. Again, some of the different diagrams on that. This gets into operating underwater. This is the example where I'm saying if you're okay if the tool's submerged, but once you get past that, that's when the breaker is going to act like a syringe and suck up water. This is talking about if the hoses start to swing or flop back and forth violently, they need to stop braking. You got to check to see that more than likely the hydraulic system's getting hot, and we need to diagnose why there's so much heat in the system. This is showing, not to operate it with the cylinders completely closed. Again, more about surface. This talks about the lubrication of the breaker with down pressure and using chisel paste and not moly. But this is available. This document is available as a handout for everybody. So that will come along with the email presentation, right, Nikki, right, Kelly? That's okay. Great. All right. All right, and there's just more of those pictures. Okay, routine maintenance. Again, this is talking about the lubrication, having down pressure when you grease it. Also, removing the tool and retainer pins often every few weeks to inspect the wear. You can see this is a good indication that there was a lot of dry fire, that the breaker was being dry fired a lot. And so until you take that tool out, inspect the retaining pins. Like I say, we recommend every 2 weeks. I mean, honestly, you can get it done at least once a month. It's a good idea to see if it's out on rent for a month, right? If it's not being used more than a couple weeks, you're fine. The other thing that's important to check is the bushing wear, and that lower bushing, you measure that by the breaker laying on the ground, and there's a millimeter of tolerance, a certain amount of millimeter tolerance between the tool and that bushing, and that can be performed while the breaker is laying on the ground. You definitely need to check with your the owner's manual for your breaker, and keep an eye on that on this. It's really important that you don't have excessive bushing wear where your tool's at, because it can cause damage internally to the breaker if this exceeds the tolerance. This is again talking typical lower bushing life is about 1,000 hours. You do need to check with the owner's manual to see what it says. A couple other things is change the carrier's hydraulic filter every 500. again, refer back to your carrier's manual, and the hydraulic fluid needs to be changed after 1,000. Now, running a hydraulic breaker, if you on the carrier manual, it'll tell you that it'll cut the hydraulic oil in half, the life in half. So if you have a machine dedicated to only running a breaker, then you probably need to change your hydraulic fluid at 500 hours instead of 1,000. But a lot of times you have breakers running on multiple machines where, there's more hours being put on your skid steer or on your excavator in trenching or whatever. So that's where just keep an eye on that hydraulic fluid. This is where I was saying that it's important when that lower bushing has excess wear, your tool alignment will be affected. So if you don't have good flat contact between the piston and the tool over time, what can happen is there could be stress fractures in your tool where eventually the top of this tool breaks. And when that happens, if the rental customer continues to run the breaker with this piece broken, we call that cannonballing. So this piece of steel will be bouncing in between the tool and the piston, and it'll form a ball inside there. And then what'll happen over time is that your piston will become concaved, and to where it's going to require the whole piston to be replaced. When that happens, a lot of times you end up replacing the entire breaker versus the piston because of the cost to do that. So that's where keeping an eye on the bushing is really important. So yeah, proper tool alignment. The other thing is, on a daily basis, it's just important that you're checking the bolts, everything, to make sure everything's intact. There's no bolts missing on the breaker. There's no loose bolts on there, that the pins are in good working order. There more than likely is torque specs on these. When we send our breakers out, we do put torque marks on there, so it's a quick visual inspection that everything that's torqued is torqued properly with the torque line. But that is something, this is saying a visual inspection every 8 hours, every 40 hours, going back through, making sure everything's tightened and torqued down properly of use. And then, so this is just a periodic check. So the gas seal, replace every 600 hours. Be sure that you're taking a look at the owner's manual for your breaker to see, what kind of service intervals they have. This is just a general idea. Now, I will tell you, one of the difficult things about hydraulic breakers is, what is 600 hours? How are we measuring time on a hydraulic breaker? Because you may send it out for a 1 week rent. That doesn't mean 40 hours went on the breaker. Realistically, that thing may have worked, 3 hours a day. So out of the 5-day work week, it only worked 12. That's where on the market today, there are hour meters, and also telematics are starting to become a big thing now as well. We currently offer both. We offer an hour meter that can be on there to be able to gauge the true hours on the breaker, and we also offer a telematic unit as well, so you can not only see the actual operating hours, but you can see how the breaker's operated as well, where in the world it's at, different things. So that's one of the things that's helping close the gap on how many hours are truly on the breaker. Hydraulic hoses, every 2 years or 4,000 hours. I mean, it's a good idea that those are being inspected for cracks. And if you notice anything that breaks or cuts in the lines, that they're getting replaced. You don't have a breaker out on a job site and the hose bust, and then that's a service call for you. Nitrogen gas. So it's important, again, to periodically check the gas. We recommend checking it once a month if it's during the season and the breaker's being rented. Often that you just double check the nitrogen gas pressure. On breakers with accumulators, they're going to typically have a couple different spots and a couple different measurements. So be sure that you're taking a look at that you're checking the nitrogen. I started my career with a company in Arizona selling equipment that we sold and rented breakers that had accumulators. And it's going to take us right into the next section, but our yard guys would just leave those breakers laying on the ground. And I had one particular year that 9 out of 10 of my breaker rentals went out, and the customer called me and said, Doug, the breaker's firing, but it's not hitting hard. And lo and behold, the nitrogen, or the accumulator, had leaked out all the nitrogen. So we had to send a service truck out there to put nitrogen into the accumulator for it to be fired. So this is something that, again, it's important that it's checked, because depending on the type of breaker, they will cycle, but they won't hit very hard. And your customer will pick up on it pretty quick. And then it's costly, of course, to send a service truck out to a job site, or if they have to bring the breaker back. So check with the like say your owner's manual, operator's manual, on what the pressure needs to be at. And hopefully they come with some kind of a nitrogen test kit that you're able to get in, that has the right fitting to be able to test the nitrogen. Okay, now we're going to get into proper breaker storage. So here's a photo of what I would call improper breaker storage. This is a photo I took in Canada, and you can see the breakers that are just lying down out in the snow. And a couple things. So when the hoses, these hoses are just just down in the elements, right? So they're gonna pick up moisture. If once the snow melts, it's gonna be muddy. If with these hoses just laying down on the ground, if there's any kind of debris and those get hooked up to your machine, you're introducing foreign objects, dirt, rocks, whatever, into your hydraulic system, and can cause a lot of damage. And this gets into the other part of, let me go back to this. The other part about this is with moisture, when breakers are laying. Now, breakers that are at an angle like this, it isn't the end of the world. But the ones that are laying flat on the ground like this, moisture can get in inside of that strike chamber that we talked about earlier. And this is why it's important, is the pistons inside the breaker, they're highly polished steel. If they get moisture on them, they will rust. It's not the possibility, they will get rust on them. So this is the area of concern that we're talking about, and this is what we see. So you had a breaker that ran great last summer and fall. You had it sitting in your yard, just laying down on the dirt. It rained, it snowed, it froze, it melted. Then you hook it back up to go out on a job for late March, April, May, and the customer runs it for the first 10-15 minutes. If this rust occurs, it's going to wipe out the seal. So now you're going to get a call that the breaker is leaking hydraulic fluid, and it's because of the way the rust that built up on the piston side. Because inside here, this isn't the best picture, but there's a part of the piston that is exposed in the strike chamber if the nitrogen gas isn't removed. So we're going to talk about that too. So here's a few pictures that I've taken across my territory of different ways that people will store their hydraulic breakers. So some stands had one company that took a broken boom arm and mounted pockets in to store hydraulic breakers. This is some type of shoring. Another customer, this is in Idaho, that actually trenched out an area and put in concrete and has a place to store their breakers. And there's also racking that's available as too. There's several different places that can either build them for you, or you can buy them for storing the breakers. So the other thing, like I mentioned before on that picture, is if at this angle, if there is any moisture that builds up in this area, it can come out. But best long-term storage is to remove the nitrogen gas from the upper cushion chamber and get the piston pushed all the way up in here, so the piston isn't exposed to any of this area. And the client, you do want to have the point down and the head of it up, and then you can cover it with plastic. And this is just an example of that. Any questions on storage, breaker storage? Okay. The last thing, and we talked about it a little bit, or not the last thing, but the next is just underwater. I think we covered that pretty well earlier. Air compressor doesn't take a lot of PSI. We're talking max 26 PSI, and breaker can be ran underwater. It's just important that the supply line stays on the hydraulic breaker. Next thing to talk about is, why did the tool break? And so you'll find when a tool breaks, there's several different areas of where it broke, but we have found reasons why, and so this kind of spells out why the tool broke. So when you start seeing these type of cracks on the top of the tool, it's usually because your bushing is wore, so it isn't in proper alignment with the piston. Fractures here have to do with blank fire, excessive wear bushing, or the front head. So some more of that lower bushing wear. And this has to do with wore out retainer pins, and again, blank firing. So that's again why we recommend that once a month, when the breaker's in regular, being rented out regularly, that those retainer pins are pulled and inspected to look at. This one we see occasionally from prying. So you shouldn't pry with a breaker. A breaker isn't meant to be a pry bar. So you have a customer that's breaking up a driveway, and he has a big piece of concrete, and he's prying on the concrete to flip it over. Excessive amount of doing that, or even if he's in a rock and twisting back and forth trying to pop the rock apart, that is where you'll see breaks that occur in this area. And then if on a chisel, when you see these tips start to bust, they probably weren't at a 90-degree angle busting the rock. And then again, mushrooming, fast wearing cause. This one we have seen. So again, we talked about if it doesn't break within 20 seconds, reposition. We've seen and heard stories of customers or having operators run breakers for 3, 4, 5, 6, 10 minutes at a time, just staying on it, hammering away. Well, as I mentioned, the steel gets hot. And so if they're running it for that long, it'll actually cause the tool to mushroom. Like the steel is starting to melt. The last one is, this is the type of break that there was some kind of an issue with the metallurgy that it wasn't heat sealed properly, that there's a pocket of air that was caused. That typically, you have to go back to your manufacturer, but that typically can be warranted. So we went through a lot of them. This is very rare, but it does happen occasionally, where when and this is the type of break that it looks like. You'll see a pocket in there, which is like an air pocket that happened during the heat treatment process of it. Next thing I have, and this is something that you'll have available to you as well. This is a rental ready, or the ready line, and then also a checklist. And when you get your copy, you'll see that there's little boxes here. So what needs to be done to get the breaker ready for rent, what you need to check when the breaker comes back. So this is a generic form that can be used. Some of these, it talks about flow tests or setting up the flows and pressures on the machine. Once it's done, it's done. But anyhow, this is also, so and this will be available to you in the email that's sent out after the presentation. So with that, open it up to any questions that anyone may have. Any questions?
Yeah, thank you so much, Doug, for sharing this information with us today. This presentation has been incredibly informative. So,
Thank you.
as Doug mentioned, we're going to open it up for questions here. So, feel free to take yourself off of mute and ask any questions that you might have, or feel free to put them in the chat too, and I can read them out here.
Yeah, hi, this is Hamida from 413 Hub. I have a question for you.
Yes, go ahead.
Yeah, we have some machine. I cannot adjust the or hydraulic flow, or I cannot adjust the hydraulic pressure on this one. So what's the best way to adjust to match the breaker with the machine?
So what brand of machine do you have?
We actually we don't have. We have the Hitachi 5 tons, or have 3.5. This machine doesn't have any flow control, and they don't have any pressure control for the auxiliary.
Understood. So it's like a Hitachi ZX35.
Yeah, 3.5 or 5 ton. Or, yeah.
Typically, and you know that's a great question. So when you're talking about the mini excavators and the skid steers, they're typically speaking, you need to any hydraulic breaker. It's going to have a range, right? So so many gallons a minute, so much pressure in there. Majority of the time on that class machine, most 500 foot-pound, 550 foot-pound breakers are going to be plug and play. You don't have to adjust your flow or pressure on them. It's typically when you get up to, I would say and Russell, David, feel free to correct me, but it's usually when you start getting into the 13 metric ton and larger, that's when it becomes more critical that you're adjusting the pressure and the flow. On the mini excavators, especially, I'm very familiar with that ZX35, and that's a 550 foot-pound breaker all day long. It has plenty of flow, plenty of pressure to be able to operate a 500 foot-pound class breaker.
Okay. All right. Sound good. For the nitrogen gas, how often should I check the gas pressure on the breaker?
So it really depends on the brand of breaker, and I would definitely have you refer back to the operator's manual on that. With ours, we because we're talking about pretty low PSI or low bar nitrogen, we recommend checking it once a month. But I have customers that have ran our breakers for years and have never checked the nitrogen gas. But I would have you but I sold breakers when I was selling equipment that if we didn't check that nitrogen on every rental, there could be issues. So I'd have you refer back to your owner's manual on that. Our rule of thumb is once a month, but with different breakers comes different recommendations. But great questions. Thank you. Any others?
Yeah, I have a question too. And should we use a chisel grease on the tools? Like, should we re-grease the chisel or the tools on a breaker every time we service?
I would. So if you're talking about you're taking the tool out and you're checking your retainer pins, I would pre-lube that tool before you put it back in. It just is easier that way. It'll save you trying to force the grease gun to ensure, and then that way you know that there's good lubrication on that tool when you pulled it out. Yeah.
You said also that the bushing worn out, and how can I check that the bushing if it's worn out or not?
Let me see if I can. You know what? I still got this. Let me go back because there is going to be in your operator's manual. You should have some kind of an indication of the millimeter clearance. So when the breaker is laying down on the ground, there's a millimeter tolerance, and that's how you check that. Yeah, between the chisel and that bushing, that's how you're checking the tolerance on that. And a lot of times we're just using Allen wrenches, right? So this is a pretty big breaker that we're talking about, this 151. So there's an 8 millimeter gap. So literally you can take an 8 millimeter Allen wrench, and if it slides right in there, then we're good. If there's extra, then it's time to replace that bushing.
Okay.
Great question.
Okay, sounds good. I have another question too. Now we prepare the machine, we prepare the tools, we attach the breaker to the machine. Now our issue is we need to test the breaker outside. In our situation, now we have a muddy area. We can test the breaker. Is this good enough, or do you have other tools we can check the breaker in a rear? Is any other way to check the breaker other than putting on the mud and test it? Because the mud is not good enough to tell me if the breaker working fine or not.
Yeah, well,
The
and
ground.
that's a great question. So I've seen a lot of different things. I've seen guys, and we're talking about short-term tests. We're talking like 5 to 10 seconds that they're testing the breakers. So I've seen guys use spare tires, like old tires that they've tested the breaker hitting. I've seen guys use a steel plate. I've seen companies that have some concrete blocks that they've used. But if as long as you're in the dirt and you're not testing the breaker for more than 15, 20 seconds in the dirt with down pressure, like you're talking about, you're fine. You're fine. David, do you have any other recommendations on that?
No, basically that's it. A lot of people use, old tires, but, normally when you do that, you're basically using it for, 15, 20 seconds. That's about it. Yeah. So. Yep.
So using a steel plate is fine too. That's right.
Yep. Steel plate's
Yep.
fine too. Yep.
Oh, all right.
Yep.
Okay.
Mhm.
I would rather if we didn't.
Yeah. Yeah. I mean, you definitely don't want to run it for a minute on
No.
that plate, but you want to make sure that you have down pressure is the most important thing. So you can, and over time you'll be able to hear that the breaker's operating properly, or not. I mean, that takes some time, but you'll be able to definitely hear if the breaker is off, if it isn't cycling like normal. But yeah, it is important that you do test it. It doesn't take much, but you want to make sure that it's firing properly before you take it out, before it goes out on rent. Great question.
All right. Thank you so much. Yeah.
Yeah, thank you.
Do we have any other questions here? No? Anyone, feel free to put anything in the chat here if you guys want. Oh. Somebody. Todd is just saying great presentation, very insightful. Kale also recommended the 1-inch steel plate in the yard for the testing.
All right.
Okay. Well, oh.
Just remember, testing on metal will cause a problem with people's ears if they're not wearing hearing protection. I would recommend something rubber as a test pad as opposed to something metal.
I second that. Yeah, thank
Great
you.
tip. Okay.
I myself was thinking a bunch of scrap tracks that we were going to throw out, piling them up on top of each other or something. That would probably be best for us to have a setup at each one of our hubs, and then nobody's breaking concrete or asphalt or anything that shouldn't be when they're testing.
Great recommendation. Yes. Yeah. And you're not causing noise pollution or wearing out your tools. So no, that's very good.
Okay. Well,
Kelly, I guess I just want to again repeat, on most of the times on this small equipment, on the mini excavators, we're talking really 6-7 ton mini excavators and under, your skid steers, your walk behinds, your Toro Dingos, all the different ones that are out there. Majority of the time, those are going to be plug and play. That if we size the breaker to the machine, you don't have to go in and make adjustments. Will it happen? As I say that, most of the times they are going to be simply plug and play, and most breaker manufacturers are going to supply hoses with the breaker that have the OEM quick couplers on them that'll match right up to your skid steer or mini excavator. So we did talk about flows, pressures, reliefs. That's really for when you start getting into the larger machine, the 13 metric ton and larger excavators. Then it's critical that those flows and pressures and relief are adjusted.
So for the small machine, I do need to check the flow and the pressure and make the calculation, see how much horsepower I need.
I've done a lot with Hitachi and Deere. I would say probably in my territory, that's that in case, and we've never had to go in and adjust it. Now, as I say that, I have seen where some adjustments have had to been made to Sani excavators. But as a general rule of thumb, you really don't have to get in and adjust pressures and flows on the mini excavators and skid steers. David, Russell, Matt, do you want to comment on that at all? I just haven't seen it.
I would think the only problem that we would have with the 1.7s, 3.5s, and the 5-ton excavators would be if we have the wrong size hose installed on them and not allowing the proper flow that the excavator has set up on it. I think that would be where the problem comes in. If it needs a 3/4 hose and we install a 5/8 hose, that would obviously restrict the flow that is possible. So I think that would be more where with the smaller excavators, we would have to worry about that, just making sure the proper hoses are on.
Yeah, good. No, great point. Great point. And I'm glad you said that too. So when you're talking about like couplers for your hoses, it's important that that you don't undersize your hose, right? So exactly what you're talking about is if you have a 1/2-inch coupler, you don't put it on a 1/4-inch hose, right? That it's important that the restriction isn't built into the you don't accidentally put restriction into the line. Great point.
Hey, any other questions? Hey, well, some great questions. And again, a great presentation. So yeah, I just want to thank you all for joining us. And once again, thanks to Doug for sharing this knowledge with us today. I just want to remind everyone too that all registered attendees will be receiving the recording and a link to Doug's slide presentation and also a few related handouts.
Of the whole thing.